Okay, our topic is about the introduction to MPLS. So in this part, we will introduce some basic concepts of MPLS. First, I'd like to introduce myself. My name is Jessica. I am a training officer in APNIC, and my specialists are about routing, switching, MPLS, IPv6, and QoS. So if you have any questions, you can send the email to me. And for this session, if you have any questions, you can directly type in the chat box. You don't need to wait and just type in the chat box, and I will try to answer the questions as soon as possible. And after this session, I will share the training materials with you from the FTP site. Okay, now we will start this session. So in this part, mainly we will introduce what is MPLS and what are the basic technologies of MPLS. For example, at the beginning, why do we need MPLS? So advantages of MPLS, and then applications. In fact, advantages at that moment and with the development, for some reasons, MPLS is used in the service provider network, enterprise network, data center for some services. And the architecture, control plane and the forwarding plane. So for control plane and the forwarding plane, we will talk about labels. So in fact, MPLS major are related to the labels. So assign the labels for the control plane and with the labels for the forwarding. So the LSP setup for control plane and the forwarding operations. These are the basic parts of MPLS we will introduce. Okay, so first we will need to know what is MPLS. The multi-protocol label switching. So label switch. For multi-protocol, that means for the app layer, it can support any network layer protocols. IPv4, IPv6, IPX, and CLMP. In fact, we are only using IPv4 and IPv6. And most of our networks are IPv4 networks. And the label is a short label. Totally, it is 4 bytes. And later we can see the format. And for the label switching, forward the packets. This is a definition. And nowadays we know in most ISP, in many ISP, we are running OSPF, we are running BGP, and we are also running MPLS. So MPLS, at the beginning, this was developed in 1997. So why do we need to develop MPLS? In mid-1990s, people consider the IP forwarding. In fact, in mid-1990s, IP is the main method used in the internet for the forwarding. IP, not ATM. So IP went ATM. And so IP for the forwarding, but at that moment, because we are using CPU for both the forwarding and the controlling part, control plane. So we are considering if on each hop, we know for IP forwarding, each hop, every router, he will check the destination IP address inside the packet, and then compare with our IP routing table. IP routing table, he will compare. First, we'll use the logical end. Okay, this IP address, logical end, the mask /16, and then compare with this destination, and whether these are matched. After that, for the whole routing table, we need to get the longest matching. So every hop, we need to do this. And at that moment, people consider IP address lookup is more complex and take longer time compared with some label swapping protocol. So at that moment, people wants to use the label swapping protocol to get the fast forwarding, and it was. But you can see a label swapping. So what is a label swapping? That means if you go to a label network, if you call this the MPLS network, and so we will not based on the destination IP address. We will based on the label. A label will be added into this IP packet, and then for the forwarding, the routers, he will only check the label. Okay, what is this label? And then compare with this label, and then we can get the outgoing another label, label 30, and then also the egress interface can be found. So the forwarding will be faster compared with the IP lookup. And this is the why at that moment MPLS was developed. But with the development of the hardware, you can see the routers, they can dealing with the IP lookup also very fast. So MPLS, the initial advantage of MPLS is not so obvious. Then why are we still using MPLS? After we consider IP forwarding is still okay for us with our hardware ASIC chips for the hardware forwarding, because MPLS decouples the forwarding from routing and can support the multiple service models, can support the VPN, the layer 3 VPN, layer 2 VPN, QoS, and the traffic engineering. So because of these reasons, that's why MPLS are used widely at this moment. And MPLS, when MPLS was developed, so people compared. There are two technologies that in fact are developing, but MPLS also one. Compare with IP over ATM. ATM, people consider, okay, ATM is also using the labels, but if you only consider about the IP over ATM, so people will meet the situations. So they need to set up the full mesh. All these equipments should be set up the VC connections via ATM. Otherwise, you can see for this traffic, he will go to the bottom router and then turn it up. So in the middle, these are the ATM switches. So in fact, the physical topology you can go through this way, but the logical topology they will get they didn't get the most optimal path. But if we are using MPLS, so if MPLS is running on these ATM switches, and then because MPLS his label path is set up based on the layer 3 routing, and then he can based on this information set up the whole path and send the traffic directly. So this is also one reason MPLS is preferred compared with IP over ATM. In fact, at that moment, several technologies for the IP over ATM has been proposed, but only this one for the label for the MPLS technology, this one has been used till now. And then continue. When we talk about the services, the most important one we would mention the VPN, virtual private network. And because MPLS, the labels can be nesting. So I mentioned that MPLS is using the labels. So labels will be embedded between the IP header and the Ethernet header. And we can put several layers of the labels. So the inner label can identify your VPN size, and the public label can be used for the public network. So you can see different companies. The VPN, the company B, you can consider the VPN B. They are also connecting to the same public network. And the customer routers for the company A, they are also connecting to the same public network. So they are sharing the same network, and they can communicate with each other. And for each company, but they don't know the other companies are also sharing the same public network. And if you have another site, so this is the VPN network, and for MPLS, he has the advantage. So if you have another site of the VPN B, another site of the company B, VPN B, and you can add it into this PE, and then he just this PE router, this is provide edge router, he just configure this information, configure the VRF, and then this customer sites can be connected and can set up the connections with the other PEs, because between the PEs they have already set up the neighbors. So this is for the MPLS layer 3 VPN. He can set up the peers very easily. And for layer 2, so you can both enable the layer 3 and layer 2 VPNs on these PEs, and very easy. This is for the VPN application, the most important one. And also for the traffic engineering, okay, the arrows should be pointed here. So if before we have the MPLS traffic engineering, for the IP you can see the traffic will go through based on the cost. Based on the cost of the link. We can see maybe you can also simplify it to be the hops. You can see from router 1, router 2, router 3, router 6. So from router 1 to router 6, there are two paths. If you consider about the hops, and then you can see the top one as the less hop, only 1, 2, 3 hops. But the bottom one, 1, 2, 3, 4 hops. So based on the IP routing table, if we only consider hops and then the 1, 2, 3, 6, this one will be the preferred path. And all the traffic, the problem is all the traffic will go through this link. So the other link, this backup link will be empty, so not used. So but we know this link, the bandwidth is smaller, but we still want to make some use of this bandwidth. So how can we make use of the other link? And we want some traffic come here. But if for the IP traffic engineering, we will have the ECMP, the multipath equal cost multipath. And then if you set the same cost, for example, OSPF, we can manually set the cost. If you set the cost, and then the traffic will be 50% from the top one and 50% from the bottom one. But in fact, we don't want to realize the load balancing because for these two links, the bandwidths are not the same. So what we want to do, we want to realize some unequal paths. And for the traffic engineer, for the MPLS traffic engineering, we can realize this. How to do it? So from the router 1, we can set up the two channels. And then in the channel, we can add some information. For example, available resources. You can define what is the bandwidth has been reserved for this channel. Okay, so 300 MB. And for the bottom one, we can set 50 MB. So for different channels, we set the different bandwidth, reserved bandwidth for them. And then you can guide the traffic to, some traffic will be guiding to the channel 1. Maybe you will consider, okay, the video traffic will be bandwidth requirement will be larger, and then I will guide into the channel 1. And for the voice, we'll guide into channel 2. So you can guide the different traffic go to different channel to realize the better utilization of the bandwidth. This is the advantages for the MPLS traffic engineering. He can realize this. And also you need to pay attention. For the MPLS traffic engineering, the decision is made on the router 1. You can see made on the router 1. But for the IP traffic engineering, in fact, go through this link or this link, we cannot make the decision on router 1. The decision is made on router 2. So based on which point will be used to go to different directions. But for the MPLS TE, we can make a decision from the source of the traffic. These are some differences between IP traffic engineering and MPLS TE. And yes, some parts can be reached by MPLS TE. That's why nowadays for many service provider network, and we are using traffic engineering. And another reason is that traffic engineering can support the faster reroute, the backup. So if one channel is down, and then we can use the other channel to back up all the traffics. So this is also another reason MPLS traffic engineering is very important for the service provider network, the backup. Okay, and the quality of service. Here we have mentioned MPLS also can support the quality of service, but MPLS, he doesn't define new quality of service architecture. Nowadays, you can see in IP network, we are using a deep self quality of service, deep self QoS. And the same in the MPLS domain, MPLS network, we are using the same, the different service QoS. So we will color the packets, and for different colors, we will treat them differently. But for the MPLS QoS, we are using some other parts to mark the information. So color, also we can consider the mark. So for IP packets inside the header, there is a DSCP, differentiated service code point. And then we will use this DSCP to identify, okay, this DSCP EF and this is voice, and then for different value, maybe for the DSCP 0000 all zeros, and this means the internet traffic. So we will use a different DSCP code to represent a different type of the traffic. And similar in MPLS QoS, we are using a similar differentiated service. So we will use the traffic class, 3-bit traffic class inside the MPLS header to color the packets. So this is the QoS implementation in MPLS. The principles are similar, just to mark the packets, and then we will treat them differently. And for the marking parts, MPLS is marking inside the MPLS header. IP packets are in the DSCP in the IP header. So this is the big difference, but the other parts are similar. You can see also the functional components and where they are used. These are the similar parts. Okay, these are mainly about the applications for MPLS T and the advantages of MPLS T, MPLS QoS, and the VPN. And here we can see, compare with normally when we are learning MPLS, and we will compare with the IP and the Ethernet. IP is the network layer, and the Ethernet is the interface we are using very widely for the data link layer. And you can see, this is just a conclusion, and we just have an overview of this information. We will not go very detailed for each point. And you can see for the forwarding, MPLS is based on label, so he will check the label and forward the information. Later we will explain. And for the TTL, we can support TTL, and later we will also see inside the label that we can support TTL. But for the Ethernet, we don't have TTL. So that's why we have the broadcast storm, because the packets, they will broadcast to the others, and then the packet will never die in the cycle. So no TTL support for the Ethernet. And for the MPLS, he can use for the control plane. Control plane, that means who will distribute the labels. Routing protocols, BGP, for example, he can extend to distribute the labels. And the label distribution protocols, for example, LDP or SVPTE, can distribute the labels, control plane. For the IP, the control plane are the routing protocols to set up the routing table. And the packet encapsulation, IP has the IP header, and in front of IP header, there is the 802.3 header for the Ethernet header. And the MPLS, we will put the MPLS label between the network layer and the data link layer. Later you can see. And the quality of service, and we can see for the inside the IP header, there are 8 bits type of service. And for the Ethernet, there is the 3-bit in the VLAN tag. And for the MPLS label, there are 3 bits for the traffic class. And we have mentioned in the previous part. And for the OAM, MPLS, he has the MPLS Ping and Trace route. At the end of this slide, we will have the example. So in fact, these informations most of them we will mention in the following parts. The technologies but this slide will be very useful for you if you want to compare IP, MPLS, and the native Ethernet. Can help you to distinguish them and also to emphasize the differences. And for the MPLS evolution, in fact, MPLS, all these technologies are published. You can see the first MPLS RFC released in 2001, so not very early. And the working group are founded from 1997. And before that, you can see different companies, they announced the label switching plans. And you can see, many people should know, Cisco has the tag switching, this technology, and the MPLS has been standardized. Some parts are from the tag switching and from different technologies, because different companies, they have proposed their technical papers. And we can see for the development of the MPLS, mainly are about the layer 3 VPN and the layer 2 VPN and the MPLS TE, and also has the, in 2010 there is the label switching multicast. And here for the TP is the transport profile. MPLS, simplified MPLS profile used for the transport network, for example SDH and this path. And nowadays we will optimize MPLS for the cloud. And for SDN, you can see Cisco has, in fact, this is already standardized for the segment routing, and this is also using the label for the forwarding nowadays. So this is the evolution of MPLS. Many applications are the layer 2, layer 3 VPN and the traffic engineering, and with some multicast and for the transport profiles. And so here, this is the conclusion of the application of MPLS. You can see if this is the core path on MPLS network, service providers network. And so our enterprises, maybe they are connecting to the service provider via layer 2 VPN. Okay, they said, okay, I want to maintain my routing. I don't want the service provider to maintain my routing information. So, okay, I will use a layer 2 VPN. And for some enterprise, they consider, okay, I can ask the service provider to manage my routing. So they will use a layer 3 VPN connecting with the service provider network. This is for different VPN. Maybe for layer 2 VPN, you are using the VPLS, and maybe using the VLL. So based on your situation and whether you want to use VPLS and or maybe VLL point-to-point layer 2 connection, VPN connections. And for the MPLS core path service providers network, maybe they will run the traffic engineering. For example, for P1 to P3, we can set up the major traffic engineering path, and we can set up the backup path. So the maybe hot standby. So when this main path is done, and then the backup path can be used immediately. So for the forwarding, the traffic will not be affected, because nowadays for our network, the traffic loss, the delay, these requirements, we want to decrease these numbers, the effect of the network. So if there is any failure of the network, we want to find the protection immediately. So that's why we are using the hot standby, traffic engineering hot standby in the service provider network MPLS core path. And for the QoS, you can see QoS similar, just at the edge, we will have the traffic marking. We will mark the information. Okay, so whether this is voice and whether this is a VIP or some information, and then traffic place and the traffic shaping, we will limit the rate based on the SLA agreement. What is the SLA I provide to you? I provide only 2 mega for you, and then I will limit the rate, the place and the shaping. And inside of the MPLS network, same quality of service operations and the congestion management, congestion avoidance. Maybe I will, based on some queue, to limit to manage the congestions, and maybe have some early job to avoid the congestion. So these are the QoS operations are very similar to the IP QoS, and the MPLS just the VPN and TE. These are implemented. And for some enterprises, maybe they want to have their own MPLS services, so they can use MPLS connector with the service provider's MPLS network, and they want to manage their different branches. So these are different application scenarios, but most technologies are listed here. And then after we have introduced why do we need MPLS and what are the advantages and application scenarios, now we are moving to the basic technologies on MPLS, going to some technical parts. Okay, so for MPLS architecture, we mentioned the control plane and the data plane, so we can forward the packets. So for MPLS, we can forward the packets. In fact, this is one router. This is one label switching router. And then when we talk about the forwarding path, we can use the label forwarding information base. So check the labels and then forward the information. And how to generate a label information base? We can see inside the router for the control plane, they have the IP routing protocols and label distribution protocols. So that's why in your router you will run OSPF and you will also run LDP. So OSPF is here. OSPF is here to exchange the information with other routers, and the LDP and maybe XVPT and is here. He is exchanging a label binding and with other routers. So the IP routing protocols, we will calculate to get the routing information base RIB. From the RIB, we can generate the FIB information. So FIB is used for the forwarding. FIB is used for the forwarding for the IP packets. You can see if incoming is IP packet, we can use the FIB to check. And for the label distribution protocols, he can generate the label information base. Okay, I will reserve some information and reserve this label for this prefix and receive some other labels for some prefix, communicate with other routers. And based on the IP routing table, what are the prefixes on the IP routing table? And he will generate a label forwarding information base. So this is the control plane. So you need to check whether the IP routing protocols are running properly, and you also need to check whether the label distribution protocols are running properly and whether the neighbors adjacency has been set up. After that, what we are using the forwarding information base, forward the incoming IP packets. Maybe you need to add a label. Okay, later you will send out with the labeled packets. And if incoming is a labeled packet, and then we will check the label forwarding information base. So these are the two planes, and then we need to know for different paths. Okay, for label distribution protocols, you need to check whether the labels has been set up, and then check the forwarding information base, the label forwarding information base. Check on the routers, and for different entries, whether he has generated the incoming, what is the incoming label, what is the outgoing label. This information should be set up. So these are the major architecture for MPLS. Some technologies are listed here. And for this MPLS technology, we can see the topology we will always mention like this. From the IP domain, if this is the IP domain network, and then send the traffic go to the MPLS domain. And in the MPLS domain, and we will add the labels. These routers, we call them the label switch router, LSR. They can support MPLS. They can check the labels. They can swap the labels, add the labels in the router, in the packet, and forward to next one. Next one can based on the incoming label to check the path and forward the information. So the border on the edge, these routers connecting with the IP domain, and then we call these are the LER, the edge LSR. And for the whole forwarding path, label switching path, we call this label switched path. on this path, we can use the label for forwarding. And we can also use the IP for forwarding. Okay, so because these are also the IP supported routers. So inside the MPLS domain, for some destinations, if there is an LSP, he will use the label for forwarding. And in the IP domain, they can only receive the IP packets because they are not enabled MPLS. So this is the topology. In this topology, we have learned the LSR, LER, and LSP. LSP will be set up. Okay, and so what is a label? Here we want to mention the label. Label is MPLS label is put between the data link layer header and the layer 3 layer. Normally we will say the network layer, but in fact, if this is put in front of the network layer, normally this is for layer 3 VPN. But if this is a layer 2 VPN, and this MPLS label can be used both the two data link layer headers will be in this packet. So one data link layer header here, and then after that another layer 2 packet. That is for the layer 2 VPN. Okay, and this is the format of MPLS label. How many bits? 32 bits for the MPLS label. And inside of these 32 bits, we always say label and maybe the value 20 or 30 or something. In fact, label's value is only occupy 20 bits. 20 bits for the label. And then for the rest 12 bits. For the rest 12 bits, there are 3 bits. These 3 bits, we mentioned this before. Traffic class. This is for the QoS part. And we will change this traffic class, these 3 bits, to represent different services. And then TTL, 8 bits. We know TTL because time to leave. IP has the TTL. And then when the packet, after one hop, the TTL will -1. And then if the TTL is 0, and the router will drop this packet to avoid the loops in the network. Okay, and here S. S is bottom of the stack. Later you can see we will explain. So if S is 1, that means this label is the bottom layer, is the bottom label. And if S is 0, that means inside there is another label inside the encapsulation. So here is about the label stacking. Label stacking, this one is used for example, VPN applications. We need to use the label stacking because one label, the inner one near the layer 3 packet, this label will identify from which VPN, and the outside, we call this is maybe the out label. This out label is used to send the packets in our public network. So for the public network, they would only read the outside label, and then inside is used to identify. This is for company A, not for company B. So this is the private. We call this is the VPN label. So two layers of labels are presented here. In fact, there can be 3, 4, or 5 layers of labels. For example, if you are running layer 3 VPN, so 2 layers of labels. And if in your public MPLS service provider network, you are still also running traffic engineering, and maybe another label for the traffic engineering will be added. So this is for maybe the other label, and maybe for the inter-AS VPN communication, and then there would be also 3 layers of labels will be added between them. So multiple layers of labels can be added. And then go to our topic S. So different layers of labels. So we have the S bit to tell the router. If S is 1, that means inside is not the MPLS, inside is the IP, and then you need to use the IP for the forwarding. That means this is for the last label, the bottom. Okay, this is the bit of S. So for the previous labels, the other ones, S will be 0. So in front of, if there is another one, S also will be 0. S0, S0, and only the last one, S is 1. So this is the label stacking. This is a very useful function for MPLS. Okay, and here we will talk about the control plane of the LSP. LSP, label switching path, and I hope you still remember. So if this is the MPLS network, and then we will consider upstream and downstream. What is upstream? What is downstream? Upstream means the water will fall from the upstream to downstream. Water will fall from the upstream to downstream. So the traffic will go from the upstream to the downstream. Okay, I will write it here. Traffic. The traffic will go from the upstream to downstream. This is for the traffic. And then we are talking about the LSP. So before you forward the traffic, we need to know which label I want to use. So who will tell the routers which label will use? The protocols. In fact, we can set up the static LSP. You can configure the labels between the two routers statically. But this will be too much configuration tasks. So we are using the protocols, dynamic setup of the LSP. So LDP can be used, RSVP-TE and the MPLS BGP. These protocols can be used to distribute labels. And distribute labels with the direction. Which direction? The labels will be distributed from the downstream to upstream. This is the same as will be very similar as the routing. Routing is like this. So for the destination IP address, destination 1, he will announce his prefix outside. This is the control plane. I will announce my IP address to the others, and then the other people can forward the traffic to me. And similar, the LSP. So labels will be distributed from the downstream. Okay, downstream, the router 4, he will tell the router 3. Use the label 300 to 100.111. So 100.111 is the destination, is the downstream. So destination is here. And then router 3 will tell the router 2, okay, use the label 200 to send the traffic to 100.111. And router 2 is the downstream for compare with the router 1. So router 2 will tell the router 1, you will use a label 100 to the destination 100.111. This is the LSP's setting up. Then after the routers, the downstream tell the upstream which label you should use. Then we can see the LSP has been set up. The label switched path. Because now router 1, he knows which label I should use for the destination 100.111. Yes, he knows, oh, label 100. Who told me? My downstream. Downstream told me the label 100. Router 2, he also knows, for the destination 100.111, I need to use the label 200. My downstream router 3 told me the label 200. And the same. So this is the LSP setup. He set up from the downstream to the upstream distributor labels. LDP will be running between, for example, if you are using LDP, so LDP will run between the router 3 and router 4, and he will send the message to use the label 300 or some detailed information are included in the message. After we set up the LSP, then on each router we can check out which out label we should use. This is the establishing the LSP from downstream to upstream. And then for the forwarding, after we have set up the path, you can see the control plane is set up via the LDP or maybe SVPT, maybe MPBGP, based on these protocols. And then we need to forward traffic. So how can we forward the traffic? For MPLS forwarding, we have some concepts, basic concepts. I think these are very familiar for some of us. One is push. Push means for this IP packet, I receive the original IP packet or maybe the layer 2 packet, and then I will add a label into this packet. And maybe also can be already labeled. For example, he has one label already inside the packet. I need to add another one to be 2 layers of labels. So this also can be the push. A new label is added into in front of between the IP and the layer 2 header, and this is called the push. And another one, during the forwarding, in the middle of some routers, he needs to change the label. I will remove the previous label and change the value to be 200, and then this change will be we call this swap. This is swap. And the pop, if I remove the top label and then continue forward the information, this operation is pop. Delete the label, remove the label. So add the label or change the label or delete the label. Oh, okay, these are the 3 operations we will call in the following slides: push, swap, and pop. So we can use the next page as the example. You can see in the previous slides, we set up the LSP. The out label is 100 or the destination 100.111. Operation will be push. Why? Because incoming is from an IP network, and then we want to add the label, add 1 layer of the label in front of the packet. Push. So add 1 label, 100. And then for router 2, he will check incoming is 100, and then we said the MPLS forwarding is faster. So incoming is 100, and from the Ethernet 1, and then the outgoing from the Ethernet 0, and the outgoing interface is Ethernet 1, and the outgoing is 200. Outgoing label is 200. So what should we do? Previously, you already have a label, and then I need to remove your old label and then add the new label, 200. We call this operation is swap, just change the label to be 200 and forward to the next router, router 3. And router 3, he will check same. For the prefix 100.111, then the incoming label is 200. We call this is a local label. Why? Why do we call this a local label? Because this label 200 is what I told the router 2. I hope you remember. For the control plane, he is using 200 because router 3 told him you should use the 200. So we added the 200 out label. In fact, this is distributed by the router 3. Okay, so that's why we call this is local label. And in some routers, we call this is incoming label. Okay, 200. And then out label is 300. Okay, 300. We still call this is swap. That's the change the label and then continue to forward. And for router 4, because incoming label, local label is 300, but no outgoing label in my label forwarding information base. There is no out label, and the operation is pop. Pop means I need to delete the label. But where is the outgoing interface? Where? I need to go to the IP routing table. So what should we do? On the router 4, we have the IP lookup. On router 4, he has done the label lookup and also the IP lookup. So he needs to check where is the outgoing interface. He needs to go to the check the IP routing table. Okay, so pop out the label and then do the IP lookup to find the outgoing interface is here. So this is the MPLS forwarding operations: push, swap, and pop. These are the basic operations. Okay, if any questions, you can type in the chat box, and if no, we will continue. So for the forwarding operations, we will look at there is another technical information has been introduced, the PHP, the Penultimate Hop Popping. This is used for the Penultimate Hop Popping. So why do we have the Penultimate Hop Popping? Because we will look at the router 4. Look at the router 4. Router 4, you can see he checked the label forwarding information base, and he also checked the IP routing table. So he checked two paths. You can see first look up the label in the LFIB and remove the label, and then IP lookup and forward the IP packet. And then people will consider, in fact, for the forwarding, he is using the IP lookup. So for the lookup the label in the LFIB is just remove the label. So these operations maybe is unnecessary for him. And then so people consider maybe the first lookup is not necessary. So how can we simplify this? Can we simplify this operation? Because on the router 4, he checked two information base, and in fact only the last one is useful. The first one, he just remove the label. That means even I don't need to know the value, and then I just remove the label. Can be just remove the label. So people has developed a technology called Penultimate Hop Popping. Penultimate Hop Popping, Penultimate Hop. This is the last hop in MPLS LSP. So Penultimate Hop is here, router 3. So we want to pop out a label on the router 3. Router 4 is pop out and do IP lookup. So we want to pop out a label on router 3. So people has developed a technology. Okay, for router 4, if he is the last hop, he will tell the router 3 to pop out a label. Okay, so they are using an implicit none. This information to tell the router 3 pop out a label. And in fact, this value will be 3. So the out label is 3, but the operation is pop out. So what should we say if you enable PHP? In fact, nowadays on the routers, the PHP has been enabled by default. PHP. So you can see push the same as before, and swap, and the router 2 will be swap. And on router 3, his incoming label is 200. Outgoing label is implicit none. Implicit none, that means the operation is pop. So a special value 3 will be used here. So on Huawei routers, you can see the out label will be 3. On Cisco routers, it will be the implicit none. So different vendors, they are using different information to tell you the penultimate hop is to pop out a label. Pop out. Then after on penultimate hop, we have already pop out a label. On router 4, so he will directly go to the IP routing table to check where is the next hop to forward the packets based on the IP routing. So this is the PHP used for most of the vendors, and then to simplify the forwarding. PHP. Okay, this is one technology we want to mention for the forwarding. And then for the OAM. For the OAM, we have the ping or tail or trace route. Before we go to that, we know there is a TTL. The TTL, time to live, in the MPLS header, we have 8-bit TTL. So IP packet, he has his TTL. And for our MPLS, he also has the TTL. So how to process the TTL for two headers. So here, this is the common process. So common process is like this. This in the middle, this is the MPLS domain. And then for the IP domain, if there is one package come in, the TTL is 251. And then we will add the label. What is the TTL? You can see the TTL will be 251 minus 1. And the same as what inside the IP packet. IP packet also minus 1. And then continue for the next router inside the MPLS. You can see he will decrease only the label TTL from 250 to 249. And for the penultimate hop, you can see the TTL in the label will decrease 1 and then copied into the IP one. So you can see IP package by default is 250. Before is 250, and then now we will copy the 248 into the IP packet, and then the egress will continue decrease. So this is normally what we are doing. We just copy the TTL into the MPLS path. So then we can prevent the loops, implement the trace route, prevent loops. This is by default enable TTL we call this is the TTL propagation. So we copied it into from the IP to the MPLS, and then from MPLS to the IP. Propagation is enabled on the vendor's routers. And we can also disable. Why? Because some of the network, they want to hide the MPLS network topology. Because if you check the TTL from here and here, capture the packets, he can see how many hops inside the MPLS domain. So if for some security reasons people wants to hide the MPLS network topology, and then he can disable the TTL propagation. Yes, you can disable by using the commands on Cisco, Juniper, Huawei routers. You can enable the commands. So for example, after you disable the TTL propagation, what would happen? That means he will set the 255 for the MPLS domain. The MPLS TTL will start from 255. Whatever value in your IP packet TTL, he will use the 255. So okay, I will set the 255 for my MPLS TTL, and then for the IP TTL, okay, decrease from 251 to 250. And continue the rest part. You can imagine the MPLS part, he will only decrease the TTL for the label TTL, and then you can see IP packet he is independent. Maybe you have many hops, and then here I will decrease from 250 to 249. So for the TTL of the labels, there is no interoperations between the label TTL and the packet TTL. Label TTL is independent, 255, 254, 253. But the IP packet, they just, okay, when I want to delete the labels, I will decrease 1 and then forward the information. So this is the after disabled TTL propagation. And different, you can use the commands to disable up to your request. So these are about the TTL processing. And so if you have you can run the TTL, then we can do the OAM and ping and trace route. A trace route is based on TTL, but ping is not. Okay, so MPLS LSP Ping. That means for these routers, for your network, maybe you can see, I don't run the ping MPLS, but I can also ping. Yes, and by default, ping is using they will use the IP. If he has the IP routing table, use the IP. And so here, if you identify, I'm using MPLS ping. Okay, so he will check the label forwarding information base to go to this destination. So this is on the Cisco iOS command line. and then we can ping the MPLS IPv4 this destination, whether reached or not. And for different vendors, the commands are different, and Huawei will be ping-LSP and the LSP ping to this destination, and the MPLS echo request and MPLS echo reply from the router 1 to router 4. So you need to make sure whether you are using LSP ping or the normal IP ping. And for the trace route, here you can see LSP trace, and then we can trace route, we can see the labels. You can see here. For the router 1, we type the trace route MPLS 4444 to the router 4, and then one from router 2 using the label 200. Go to the router 2, we'll use the label 200, and then from router 2 to router 3 is using the label 19. And from router 3 to router 4, you can see which label we are using, implicit none, because router 4, he is the last hop, so he will tell the penultimate hop to pop out the label, and then using the implicit none. So this is the result when we doing the trace route command on MPLS using MPLS LSP. So these are mainly basic parts of MPLS topology, and we didn't go through the details of LDP and all VPN paths, just introduced the labels and the applications of MPLS, and introduced compare the differences between IP, Ethernet, and MPLS, and introduced the label format. There are labels, 20-bit labels, and the 3-bit traffic class, 1 bit for the stack, and 8 bits for the TTL. And then we talk about the control plane and the forwarding plane of MPLS. Control plane, you need to distribute labels from downstream to upstream. This direction is reverse compared with the forwarding path. So forwarding path, we will put labels, push, swap, and pop out labels for the forwarding. So these are the major parts of MPLS basic technology. So any questions here? If you have any questions, you can type in the chat box, and now I would share the handouts with you. This is the FTP link. You can download the handouts. And if you have any other questions after the session, you can send the email to me. And also for the member service, you can contact our help desk. You can ask for help in the